I'd like to introduce you to Colin Childs, who will be your presenter today. Colin?
Good afternoon. My name is Colin Childs and I work at ESRI's Educational Services here in Redlands, California. Joining me today is Ben Ramseth. Ben is a colleague and fellow instructor. I want to welcome you all to today's live training seminar entitled Migrating to ArcInfo 9. If you're taking this seminar, the chances are that you are an existing Workstation ArcInfo user and that you'd like to consider using the new ArcInfo 9 functionality and tools that are available to you. This seminar is specifically geared at introducing you to some of the new technology and helping you to migrate across. We're going to cover 3 topics this afternoon: workflow and geoprocessing tools, data migration processes and tools, and editing and maintaining data. Each of these topics will be followed by a brief software demonstration that'll illustrate to you some of the main concepts which we have covered during the topic discussion. We'll follow this with a review and some question and answers thereafter. So workflow and geoprocessing tools is our first topic, and this is a very important one since you need to start introducing yourself to a mindset of migrating data. So moving from Workstation ArcInfo to ArcInfo 9 is a relatively easy process, but there are 2 main considerations you need to be aware of. The migration process will require you to migrate both data, older legacy data structures such as coverages, shapefiles, libraries, or ArcStorm data, but also to migrate your workflow processes. In other words, your methods of editing, your methods of mapping or map creation, and your methods of producing outputs such as high-quality cartographic maps and so on. Each of these topics, data and processes, will be covered in subsequent topics within this workshop. When converting or migrating your data, one of the things I recommend you look at is evaluating your coverage data first. In other words, taking a really good look at your coverage data and deciding what would be the appropriate data, arcs or nodes or polygons to migrate across, and which forms of structures to use to store that information in. When evaluating your workflow processes, you need to have a look at how you currently go about executing or doing something in Workstation ArcInfo. For example, how do you go about an edit process of creating a new spatial data set? And then how do you clean it? How do you build topology? How do you validate it? So those are the things we'd recommend you evaluate. In our subsequent sections, we'll cover each of these in more detail. One of the things I'd like to introduce to you is a brief overview of the different types of applications and how they compare with each other within Workstation against ArcInfo 9. Now, as a Workstation ArcInfo user, the Arc prompt is one of the most important prompts or application areas you use most often for data management, for data conversion, and of course for reprojecting and building topology. Well, similar functionality will be found in the ArcInfo 9 environment within ArcCatalog and in the Arc Toolbox environment. If you're an editing individual or person who does a lot of editing, you'd be aware of the ArcEdit environment and the ArcPlot environment if you produced maps or displayed and queried your data in Workstation ArcInfo. The equivalent of ArcEdit and ArcPlot is the ArcMap application in ArcInfo 9, and it's here where you do map display and creation, query and analysis, and also the editing that you normally do. Many of you have used the Kogo extension of ArcEdit in Workstation ArcInfo and will be familiar with Kogo functionality. Most of this functionality is now core to the ArcMap editing tools. In other words, what used to be an extension you would have to purchase in Workstation ArcInfo is now a set of core editing tools in ArcInfo 9. If you'd used ArcStorm and Librarian in Workstation ArcInfo, the equivalent of this would be ArcSDE in ArcInfo 9, and more specifically, the creation of an ArcSDE GeoDatabase would more than replicate and make a more efficient environment similar to what you may have used in the ArcStorm or Map Librarian environment. And for those of you that have automated and done batch processing with AML, we now offer you in ArcInfo 9 the geoprocessing tools and the ability to use models and scripts, and you can emulate and in fact be far more efficient using models and scripts than you may have in the past with AMLs. Let's continue a little further and have a look at the new geoprocessing environments in the ArcGIS 9 environment that you will encounter when you migrate across. Now, one of the most exciting things for us is the introduction of a very robust very comprehensive Arc Toolbox environment. The ArcInfo 9 Arc Toolbox will offer you around about 200 different tools to use for all sorts of different geoprocessing functions. These tools, when you double-click on them, launch a form similar to the one I'm showing you in the bottom left-hand corner of your screen at this point. That form is very typical of a tool which requires several parameters or arguments. It's very similar to using the Arc Tools environment in Workstation ArcInfo, where double-clicking on an individual function from a menu list will give you a tool to complete to execute. Those of you that did this would be very familiar with using these tools. Of course, we can't get away from a command line with Workstation ArcInfo, and the ArcGIS 9 environment introduces you to a command line within the ArcGIS 9 environments. The command line is a far more comprehensive and simpler command line than the previous command line environment. You might remember and recall having to try and copy and paste pieces of the arguments and finding it really frustrating. Well, this command line now has what we call code completion. And as you type your function or your command and the arguments in, it will prompt you and guide you for the appropriate arguments and also give you drop-down lists of appropriate data to complete individual arguments. For me, of course, the most exciting environment in ArcGIS 9 is the model builder. I'm not sure about you, but I'm really very visual when it comes to doing things. And nothing could be simpler than using a model builder environment to drag a tool and drag some data from different environments, drop them on the model page, connect them all together, set the parameters required, and to execute that model. These models can be really simple or really complex, and the efficiency of using Model Builder versus writing a program or versus using the individual tools will become very apparent to you when you start using them. This is very, very exciting and a very powerful environment for you to be aware of. Of course, Model Builder is also complemented by using the add item options or perhaps the scripting environments. In this example here, I've showed you the add item tool via a tool, the same add item via a command line, the same add item via a model, and finally via a script. So with ArcInfo 9 and ArcGIS 9 specifically, we've introduced the ability for you to script or to create programs very similar to AML using a scripting language. The example you're seeing below is a script created in Python, but this script could have been in Java or in VBScript if you wanted to. You'll notice how very simple the scripts are. They require some parameters, and then you would use, as if you were typing a command line, the same tool. A little bit more about this later during some of our demonstrations. Of course, finding the tools will be one of the challenges initially starting, and until you become comfortable, it's a good idea to have a look at the individual toolboxes found within Arc Toolbox. Notice that the toolboxes have been categorized to the types of actions that they, or the types of tools that they contain for the different types of actions that you might perform. So by clicking on the coverage tools, you would open up the toolbox, and within it you would find several different tool sets. These tool sets are a further refinement of the individual tools that you require. And by opening a tool set, you'll find the individual tools that perform single geoprocessing operations. For example, drop item or add item are typical examples of tools you would have used in the coverage environment. Now, you should be rather excited at this point because you'll notice that we have included a coverage tools toolbox for you. This means that if you do have Workstation ArcInfo installed, you could still execute many of the tools that you would have used from the Arc prompt via these new interfaces of tool, command line, model, or script if you choose to. And this is very exciting for us as coverage users. But notice also that we have several other additional complementary toolboxes for GeoDatabase data management, for cartography, for conversion, etc., etc. These tools all require you to specify a series of parameters or environment variables, if we wish, to make them work efficiently. So a right mouse click in the toolbox environment will give you access to the environment settings menu. And by placing or opening the environment settings menu, you may be able to set some general settings for workspace, scratch workspace, output coordinate system, and output extent. I might just point out at this point or at this time that output coordinate system and output extent allow you to control both the projection or coordinate system of your output data, as well as, with output extent, the extent or boundary. In other words, we can reproject on the fly any input data to a new output when we use these tools. And we can also clip data using the output extent if it is different from the input data. This is a little different from what you used to use in Workstation ArcInfo, and I think you should start seeing the advantages of doing this here, is that your input data into a model or a tool or a script can be in any particular projection and with any specific extent, but your output could be in a different projection and extent if you choose to. One of the things I'd like you to have a look at is also to execute AMLs in ArcInfo. So if you have AML programs at any point in time, it's very easy for you to execute them. Of course, AMLs require ArcInfo Workstation, and therefore to execute these AMLs, you'd need to have Workstation ArcInfo installed. Running the register AML as executable file will allow you to register an AML. You run the AML, however, by adding it as a script into a toolbox. And you'll notice that I have my ArcInfo toolbox here, and I have a tool set called AML Tools, and within that I've added two older ArcInfo macro language programs as individual tools. So you can add the tools or the AMLs as scripts into a toolbox, and they become actual tools for you to use. So let's stop at this point and have a look at a quick software demonstration in which I'm going to illustrate some of these tools for you. I've opened up ArcMap, and I'm displaying at this point in the ArcMap environment a polygon feature class from a coverage. In other words, I can display and I can query and I can map coverage data. The one thing you need to consider, however, is that if you wanted to do any editing on this coverage data from within the ArcMap environment, you do need to convert the coverage data to GeoDatabase or shapefile format. We'd prefer you to look at GeoDatabase because of all the efficiencies via subtyping, domains, and validation, which you can do. Well, where do you find these geoprocessing tools that I've just shown you? And you'll notice I've moved my cursor across to an icon on the standard toolbar. A single click on this icon will launch the geoprocessing tools via the Arc toolbox. Now, this Arc toolbox may be positioned anywhere on your interface. You can drag and drop it, you can have it floating around, you can even put it somewhere on your screen as an undocked window. Now notice that inside of the toolbox are several different tools. Tools for data management of GeoDatabase data, tools for conversion to and from the GeoDatabase. For us as coverage users, we may want to look at the coverage tools, and perhaps we'd like to look at the data management tools of the coverage, and many of you might recall the join item command found in a tool set called join. Double-clicking on that tool will open the tool for us. And notice how quickly and simply a form was generated, which allowed us to specify the input parameters for this particular function. So I could, for example, drag data from my table of content. In this example, I might do so. Or I could search for this data if I wish to. And in this case, I'm going to bring the coverage data and the polygons in to my function or command. I may also bring in the lookup table, which I'd like to join to this PAT file, and when I'm ready, choose the OK button and I would execute. I'm going to cancel at this point since I want to show you several other additional environments that you can do the same thing. So instead of using a tool, I may use a command line. Notice the command line has now been added here. As I start typing in individual command names, notice how the code completion gives me the actual commands that are available that start with the key characters of J in this example. I've chosen join item, and as I progress with the arguments, notice how code completion gives me the individual parameters. As I start completing the parameters, such as this, in my system, I could get further code completion that will assist me in completing the code functionality. For me, the most exciting part, however, of all of this is to use Model Builder. And I'm going to shut this down a little, or close down these tools, and I have created a personal toolbox for myself. In this toolbox, I'm going to ask the system to create a new model. And you may recall that we can drag and drop data from different environments. So in this example, I'm going to go back to the coverage tools, and from the data management tools, I'm going to drag the join item tool across to my model. Now the tool itself is all great, or is all transparent because I haven't set any parameters. A double click on the actual tool will allow me to complete the parameters for this tool. And when I complete the parameters, it will allow me to execute that tool, or, as we'll notice in the next few minutes, it'll allow me to do several other things via the model. So here I've created a very simple model that'll take polygon attributes, lookup table, join them together to create a new output polygon attribute table. If I chose to, I could use this button and run the model, or I may choose to save the model. So notice that I can save the model here, or even more exciting than that is I can choose to export the model to a script. And this allows me to share this model or to make a simple or complex model into an individual tool. Now, I've already done this. I've created a script, and let's have a quick look at Python. And here is an example of the script generated from a previously created model with exactly the same functionality. The important thing for you to notice is that the individual tool and its functionality now appears as a step in the script program. You can take this script and further refine it if you need to. Well, that concludes my demonstration of the new tools. Let's take some questions, but before we do, a quick review. So in this last section, we discussed the migration process and the need for you to look at migrating both data and processes from Workstation ArcInfo. We've looked at geoprocessing methods, we've looked at geoprocessing environment, we've looked at the Arc toolbox, and at executing AMLs. I'm going to pass over to Ben to take some of your questions. Ben.
Thanks, Colin. I've got a question here from Ryan in Madison, Wisconsin. How many geoprocessing tools are available with the ArcInfo license, and how many are available with the ArcView license? Well, at the ArcInfo license, we have nearly 200 geoprocessing tools, and at the ArcView license, there's over 100. We have another question here from Bill from Texas. Does ArcMap 9 allow coverage editing, or do you need the data to be converted to a GeoDatabase first? And the answer to that is yes. If you're going to edit your coverages in ArcGIS 9, you have to do it with the ArcInfo workstation, using the command line and editing your coverage like you have in the past. If you want to use the new ArcMap and use the new desktop technology, you'll have to convert it from a coverage to a GeoDatabase feature class or shapefile. And one more question here. We've got Tom from Kansas. How large can a personal geodatabase be before moving to SDE? Well, a personal geodatabase can be up to 2.14 gigabytes. If it's any larger than that, you're going to have to go to an SDE geodatabase. I'm going to turn it over to Colin now, and he's going to do a couple more questions.
Right, I have a question from Christine in Palm Beach asking, if a model is to be rerun repeatedly, can you edit the model inputs and outputs? Are there simple ways to script multiple inputs and outputs in any of the environments, such as Model Builder? And Christine, yes, it's very simple for you once you export the model to a script, or even if you just keep the model as a standard model, you're able to take the parameters that are there and you're able to assign individual inputs to each of the parameters. In other words, each single input for coverage data or shapefile or whatever it is you're using can become a separate parameter, and the system will automatically generate a form for you that will allow you to do this. Question from Joanne here in Kansas is, can I store images, raster images, in a personal geodatabase? A little off the point here, but yes, you can. You can manage raster data via the personal database in ArcInfo 9 now. You can have raster catalogs and you can have raster data sets. And for those of you that are Workstation ArcInfo users, you may remember the option of a raster catalog, but we have a far more comprehensive and very important one for the geodatabase at this time. I think we need to get on to our next topic, and our second topic is data migration processes and tools. So to return back to our migration process slide, keep in mind that the Workstation to ArcInfo migration requires both data and processes to be migrated. We've already discussed the data processes where you need to evaluate your coverage data. Well, several additional steps are required in the migration of the data. One of those I recommend to you is to design your geodatabase before you start migrating. In other words, learn more about the GeoDatabase. Learn about what can be done and how it can be used. And take that knowledge that you've learned and apply it to a good geodatabase design. Several database design models have already been published and are available for you to download from the ESRI support webpage. You may also need to do a little coverage pre-processing before you start migrating, and you need to choose the appropriate creation method to convert from coverage to geodatabase when you're ready. After conversion, you now have potentially a geodatabase that you can start using. You may further refine that geodatabase by subtyping fields, by adding constraints via domains, or creating validation mechanisms such as a GeoDatabase topology. More about the topology in a later section. My next slide illustrates a typical coverage data migration process and example for you. On the left-hand side here, I have two ArcInfo coverages. Both of these coverages represent the same spatial area. The PLSS coverage represents survey data, whereas the parcel coverage represents simplified polygons for lots and parcels. Notice that in the coverage environment, in order to have polygon features, we had to collate point and arc features together, and we created several regions out of the polygons. In the GeoDatabase, this is not required anymore, so we do not need both labels and arcs to create a polygon. Polygons are physically stored as such in a feature class of their own. So as part of the GeoDatabase design, and part of the logical design that you may come up with, you would re-evaluate your existing coverage feature classes or coverage data structures and see where they would fit in a GeoDatabase design that you would place your data in for ArcInfo 9. And the resultant GeoDatabase that you come up with may look very different from the original coverage data. Many of the coverage feature classes will have been migrated into one or more feature classes, and perhaps you would maintain those feature classes in a feature data set. And I'm pointing at this feature data set right now. The ability to store data in a feature data set also gives us the ability to create topologies in which we can use maintenance tools. In fact, the topology will allow us to set several rules to maintain coincident geometry between the data. A little more about this in topic 3, however. So data pre-processing before you start conversion usually includes things like building and cleaning the input coverage, taking your lookup tables and other data sources and appending or join iteming them to your feature attribute table. You may also consider using map join or append if you have multiple map sheets in a map library before you convert those to the GeoDatabase feature classes, and you might consider looking at dissolving features that are not necessary. The database conversion tools found in our ArcInfo 9 environment are quite comprehensive, and there are many of them. You'll find several of them in the conversion toolbox under the two GeoDatabase tool set. These tools are being created to specifically migrate from other formats into GeoDatabase feature classes. Notice we have two tools, feature class to feature class and feature class to GeoDatabase multiple. A little more about these in the next couple of slides, however. You may also find, though, that several of the data formats that you have available, such as the legacy ones, perhaps Tiger file or a VPF format or spatial data transfer format, many of these do not have direct conversions to the GeoDatabase. So you may consider converting from these formats to coverage and then converting from coverage feature class to the GeoDatabase. In other words, you use the coverage as an intermediate format, a temporary format if you want to, before taking the data into your final GeoDatabase feature classes from these older formats. Now below here, I'm indicating to you a good example or a typical example of the use of the feature class to GeoDatabase multiple tool. And in this example, and I'm pointing at these for you, we're taking parcel coverage arcs, parcel coverage polygons, and we're doing a conversion of these to the GeoDatabase. Now notice that the tool has been highlighted to indicate that the parameters have been set. A derived GeoDatabase has been created for us by the model. This is a staging database, if you wish to, a temporary one, and then the final result, when the processing is done, has been written to our target GeoDatabase. All very simple and very easy to use. So I'd urge you to start looking at the ArcInfo 9 tools and specifically looking at Model Builder because it's going to be so efficient for you to use this to speed up processes of batch movement and so on of data. Now, populating the GeoDatabase feature classes can also be done in several other ways. So we've already looked at the feature class to feature class conversion. But you may also use the import functions to import from our catalog and our toolbox directly into the GeoDatabase. In this case, the source data that you're importing will define the structure of the feature classes that will be created. You may also consider using the simple data loader in our catalog or the ArcMap object loader. These require you to have the feature classes that you're loading into already created. And what you'd be doing is literally appending new data into these feature classes. The simple data loader and the object data loader differ slightly in how they work. Simple data loader, found at the Arc catalog prompt, does no data validation and is an extremely quick tool to convert or to append data in. The ArcMap object loader, however, is a little slower, roughly a second per feature, but it does validate as it loads features into an existing feature class. I'll be demonstrating some of this in the next few minutes to you. One more area that I find very important to discuss with Workstation ArcInfo users is the import and export of CAD data. Now, keep in mind that the ArcGIS product has the ability to do a direct read of CAD data in native format. In other words, many different CAD formats do not need to be converted if they're only going to be used for display and for query. But if you need specific CAD geometry, or if you need to pull out some of the attributes from the CAD environment, perhaps the CAD environment has several pieces of information attributed in a block entity in the CAD dataset, then I would recommend you look at using the import from CAD Geoprocessing Tools. These are very, very comprehensive in ArcInfo 9 and have been significantly enhanced in the recent iterations of our software. They employ scripts and models, and what they also use is a staging or intermediate geodatabase to convert to before writing out the results to our final dataset. And lastly, we also have the ability to export out one or more GeoDatabase feature classes to a single CAD output if we choose to. In other words, we can create DWD, DWG, DXF, or DGN files from one or more input GeoDatabase feature classes. Now, the graphic I'm showing you here is a typical workflow scenario for conversion of CAD data. I'm pointing at the DWG file, and from this we have selected point layers and polygon layers. These two layers represent final polygons which we'd like to create. The point layer, however, contains a block entity with attributes we would wish to assign to the output polygon when we create it in the GeoDatabase. So intermediate layers or GeoDatabase feature classes have been created of the point data and the polyline data. Then these have been further broken down, and the points that we require with their block entities have been isolated. The boundary layers have been filtered with an expression to find only those boundaries we want to convert. We then have two more additional intermediate data sets created. These two have been collated together or appended in one via a model to create a new output polygon feature class in the GeoDatabase. This may look fairly complex, but let me assure you that the process is actually very, very easy, and in fact, a very simple process for you to do via the modeling environment. Let's continue with a brief demonstration and show you a little bit more about how these tools are put together and worked. Now, before we start, we're going to have a look at the Arc catalog environment. And in this environment, I'd like to illustrate that I have several different data sets in different formats. I have land parcels, which is a shapefile, and I know this is a shapefile via the green icon that is being used. I also have subdivision lines. This is line data in a shapefile format. I also have, at this example, a CAD drawing called New Subdivision. Now, the New Subdivision CAD drawing actually has two instances in the catalog tree. Notice that it appears as a data collection in which I can view the individual layer, well, not layers, but layer categories. So I may view polygons, or I may view the polyline layers. But the CAD also has a second instance called the New Subdivision, And this shows me one single unified CAD drawing without the option of differentiating, as I had earlier, between different layers. Now all of this leads me to the actual data conversion. Now I'm going to do this conversion in ArcMap to illustrate how simple it is. Land parcels, the current display that you're viewing here, is the shapefile that I illustrated to you earlier. And I have several options for converting. I may choose to use the Geoprocessing Tools at this point, and I may choose to use the conversion tools and two GeoDatabase tools. And I might pick the feature class to feature class conversion tool, and if I wish to, I could execute the conversion via that tool. I would very simply drag across the shapefile and drop it in, specify the output location, specify the output feature class, and refine which attributes will be converted when I do the conversion. I'm not going to do this at this point. I'm going to cancel because I'd like to show you an additional way of doing this conversion. One of the conversion options I have is a right mouse click in the table of content, and I have the data export option. This implements the same type of functionality but in a very simple tool. And notice that the output feature class created could be shapefile, could be personal GeoDatabase feature class, or an SDE feature class. Very useful indeed. I've actually already done this, so I'm going to show you the result in the next few minutes. For the CAD dataset, which I know fits really nicely in here, I have only filtered out to show you the polygon CAD data. And again, I have several different options for data conversion. I may use the Geoprocessing tool, and I may use the import from CAD tools to do this conversion. Very simple to do, very easy to do, or I may use a model to do this. I'd like to show you, however, a third way, which a lot of people haven't considered, to do the conversion. I'm going to switch my data frames by activating a data frame with my converted shapefile in a GeoDatabase feature class format. So notice that I have some missing data here. This missing data happens to be the CAD new subdivision. But instead of using a conversion option and trying to append this data into my GeoDatabase feature class, I'm going to start an edit session for my current parcel data feature class, which was derived from the shapes, and I'm going to choose a create new feature task. And I'm going to use a tool called the load objects tool. Now you may recall I mentioned the simple data loader and the ArcMap data loader. So the load objects tool will allow me to input the CAD data set that I had shown you earlier. And in this case, I'm going to use from the CAD data set only the polygons here. Choose the OK button, list those in, and I'm going to use the simple defaults in this wizard to do the import. Before I do, I'm going to move this aside a little so you may keep notice of this area here that I'm indicating with my mouse. So choose the next option, use the defaults, and finish. And here I have it. I have now used the ArcMap object loader to load the CAD features directly into my GeoDatabase feature class. And how do I know this was successful? Well, I can do an identify. I can do a selection. I can select multiple features if I choose to. And I may even view the attributes of these features. And I can do that by using an open attribute function. I might just bring this down and show you the selected records. And those are the features that I had previously selected. That concludes this demonstration. Let's take a few minutes to review what we've just covered and take some review questions. Before we do, at this point, I'd like you to link or to click on the link in the upper left-hand corner of your browser window. This will bring up a review question option for you. And on my next slide, I'm going to show you an actual review question. So at this point, please click on the link option for the review question. My review question for you today is, which data conversion method will ensure that your data is validated? Choose from A, B, C, or D. Submit your answer by clicking one of the options and the send button. In the next topic, during the next topic, we'll bring up the option and tell you how many of you managed to answer the review question correctly. So in review of our topics discussed in this last section, we spoke about data migration, we spoke about migrating coverage data, using data conversion tools, and the CAD import and export tools. Ben, would you like to take some questions for us, please?
Yes, I would, Colin. Thank you. I've got a couple questions here. There's Jason from Boise, and his question is, where is the geoprocessing functionality such as clip, merge, union, etc., and where is it stored in ArcGIS 9? Well, as all the functions in ArcGIS 9, they are as tools in toolboxes. For example, if you're looking for the union tool, you'd want to look at the overlay toolbox. We have another question here from Beth from Olympia. Can you integrate system commands into the model builder? And yes, you can integrate system commands in model builder, and you can also integrate like third-party scripts into a model builder, and also Python scripts and other types of scripting. We've got another question here from a user. Is Python going to replace ArcObjects? And the question, or the answer, simple answer to that is no. ArcObjects is for customization and for customizing the interface and also making your custom applications, whereas Python scripting is specifically a scripting language in ArcGIS 9 and is used to run scripts or do processes similar to what you might have done for AML. And at this point, I'm going to turn it back over to Colin.
Thank you, Ben. And we have several interesting questions here. One from Sergio in Bogota. And Sergio asks, is ArcInfo Workstation required to use geoprocessing in ArcInfo 9? Sergio, Workstation ArcInfo is only required if you're going to be using the coverage tools in the geoprocessing environment. If you choose not to use those coverage tools, you have equivalent GeoDatabase tools for clip, add item, drop item, etc., etc. So only if you need to use coverage tools will you be required to have Workstation ArcInfo available. I have another question from Steve in New Zealand, in Takarua in New Zealand as a matter of interest, and he asks, can Model Builder be used to perform geodatabase management functions such as register, unregister, create feature dataset, and so on? Steve, not really in the realm of our course or of our topics here, but the answer is yes, you can. So you can do some of the management functions of your geodatabase through the geoprocessing tools. And in fact, the plan is to have many of those day-to-day management tools available via Toolbox, and it allows you to create models and scripts to automate many of those routines and processes that you would have done. Let's move on with our next topic, and our final topic for this afternoon is editing and maintaining data. So at this point in time, we've discussed in the migration process all the data migration. So our next step would be to discuss the processes that you would wish to migrate. So we're going to discuss your editing routines, your data validation routines, your map production routines, how those would be migrated, for example. Although we're going to concentrate more on data here, so we'll talk about the data editing routines. So evaluating the workstation workflow and processes can really only be done by having adequate knowledge of the ArcGIS functionality. So you need to go and learn a little more about ArcGIS, such as taking this web workshop will give you a better idea. You need to evaluate where this functionality fits in and how it can support and supplement what you're currently doing. At this stage, you may also start thinking about redesigning your current workflow. There is no hard and fast rule. Different GIS agencies and organizations do things in different ways, and you need to evaluate your current methodology with respect to what is available now and how this would fit into the methodology you would like to practice. At this stage, you may also start thinking about creating customized applications and perhaps using ArcObjects, for example, to automate some of the things or to create new buttons and functionality there. And finally, once you have done this evaluation process and introduced these new things, you may start introducing these new workflows and methods to the people that do all the work, perhaps the editing staff or the data maintenance staff or people that work in the cartography environment and so on. Let's continue and have a quick look at the review questions. And our review question was, which data conversion method will ensure your data is validated? A, B, C, or D? The correct answer here was C, and I noticed that we have roughly 73% of you have answered the question C correctly. Thank you very much for taking our review question. It gives us a good feeling to know that you have taken and absorbed some of what we've said. So many of you, when you are working with or start wanting to work with ArcInfo 9, are very familiar with older applications from Workstation ArcInfo, applications such as ArcEdit and ArcMap. And many of you have asked us, where is the ArcEdit product? Well, the ArcEdit is no longer an application as per se in ArcInfo 9, but really a toolbar, the editor toolbar that is, inside of ArcMap. The editor toolbar is very comprehensive, and you start by using the Start Edit function, and immediately it'll activate all these different menus and tools for you. Your first step thereafter is to start choosing a target layer, in other words, which data set you'd like to edit, similar to setting your edit coverage if you choose. Thereafter, you would choose a function or task to execute. So at this point, I would like to perhaps create a new feature, or perhaps I'd like to reshape a feature, or mirror or extend a feature, or calibrate a route. These things should be familiar to you as Workstation ArcInfo users. We often used to mirror, clip, cut, and so on. These tasks require you to either, as creating a new task would, choose a sketch tool to create the actual new feature, or to use an edit tool to modify an existing feature. I may just point out at this point that the sketch tool supports the use of a digitizer. So if you have a digitizing board available, the sketch tool is able to interact via a digitizer pack. So if you do use digitizing, it's all there and available for you to use as well. The edit tool will work with existing data. Notice on the far right-hand side, and I'm going to use my cursor to point at this, we also have an attribute dialog. So if you selected a new feature or a feature to modify, that modification can be either of the geometry via the task or of the attributes via the attribute dialog. And we support batch changes to multiple features and so on. There are also further tools for editing such as the split tool, the rotate tool, and the sketch property tool. And under the editor menu, you'll notice several tools to divide, to buffer, to copy parallel, and so on. There are also a huge number of tools that are available for you with right mouse clicks or context-sensitive mouse clicks in the editing tool set. Let's move a little further on and have a look at one of the areas that I'm most excited about with respect to geodatabases, and especially for ArcInfo 9 users this should be, and that is GeoDatabase Topology. Now, several of you may have heard of this GeoDatabase Topology in the past, but might not have really realized what it can do. Now, topology has always traditionally been used to model adjacency, connectivity, and proximity. And build and clean in Workstation ArcInfo were the two tools that were used most often to do this. Well, keep in mind that we also have the topology tools in the GeoDatabase that support proximity, connectivity, and adjacency, but with one significant difference. We support it between one or more feature classes. In other words, these interrelationships can be viewed and searched for and found between features in different feature classes. So GeoDatabase Topology employs rules, a series of rules, maybe 25 of them or so, that you could potentially set to find relationships between your data. They also employ ranking or ranks that allow you to control how features are snapped together. And finally, you have the option of setting a cluster tolerance, which is the equivalent of a fuzzy tolerance in the clean command. This cluster tolerance is really an acceptable distance in which vertices would be considered to be coincident. More about the topology in the next few slides. How different is geodatabase topology from normal coverage topology? Well, remember that coverage topology is integrated into the coverage. In other words, a coverage cannot exist without topology. In the geodatabase, topology is discovered when it is required. In other words, the relationships between features are not implicitly stored, but are created when they're needed during an edit session or when you validate the topology. In the coverage environment, topology has a fixed set of rules. You need to physically build or clean a coverage, and these rules will be executed. In the geodatabase, there are none set. You have to create and define your own. So you have a lot more power, and it's a lot more powerful for you to define your own types of relationships to search for. For example, if soil polygons may not overlap each other, you could define a must not overlap rule, and this would be validated when you validate the topology. Anything that is not for or that does overlap will be flagged as a potential error in your data. In the coverage environment, we have some very basic rudimentary tools for discovering our errors. We have label error command, node errors, and many of you might have printed out edit plots and tried to overlay these on existing data from time to time, and you might remember that. In the GeoDatabase, we have some very, very powerful validation tools. One of these, known as the Error Inspector, will allow you to display errors and to zoom, find, and possibly even fix those errors through a predefined fix function. In coverages, you might remember that if you've done any editing, nobody could do anything to that coverage until you've built or cleaned the coverage. In other words, the errors had to be resolved before you could do anything else with the data for doing analysis, for example, or a buffer. It had to be a clean coverage in order to do so. In the GeoDatabase, this is not true. Errors are discovered when required, and the errors do not need to be repaired in order to do further things with the data. We can mark errors as exceptions or choose to ignore them if we wish to. Obviously, the results of analysis will be implicated if the data is not necessarily clean or in a good state. In the coverage environment, when you use build or clean, all features, all the geometry participated in the topology. And remember the fuzzy creep factor that could have been introduced into data if you performed too many cleans with large fuzzy tolerances. In the GeoDatabase, when you validate, you do not need to validate the entire data set. You can validate just specific areas. In other words, you can define the area in which validation should occur. These are called dirty areas when they're not validated. A little more about this during the demonstration. This next slide, even though it looks fairly complicated and complex, will give you an indication of the topology workflow. We create a topology in our catalog. We set a cluster tolerance, a ranking, and a series of rules. Everything is assumed to be dirty at this point, and we can choose to validate the topology and go ahead and edit the features. Or we can choose to validate the topology and view the errors via the Error Inspector. The Error Inspector will allow us to fix these errors, which in turn will result in dirty areas. Or the Error Inspector may let us set exceptions to these rules. Notice that the workflow is pretty much up to you. You can choose to validate and edit, validate and view and fix errors, or not. This is where I was pointing out that it's important for you to be aware of the ArcGIS 9's workflows, different processes, and how these fit into your current workflow in the workstation environment. This is a typical example of where you need to consider how things are different from one to the other. The final slide I'm going to show you is fixing topology errors. And you'll notice that on this slide, in the ArcMap environment that I'm pointing at right now, I'm showing you the display of the topology with a specific set of symbology in an ArcMap session. I'm also illustrating the Error Inspector that allows you to query for errors, and it allows you to specifically zoom to and find individual errors. In order to maintain topology, the Topology Toolbar also offers us several tools for constructing features, for doing topology edits of shared features, to do show shared features, and other options. More about these during our demonstration. So in summary of the migration process, the two things you need to consider is migrating your data and migrating your processes. The process of migrating the data is relatively simple, but consider database design. The process of migrating your workflows, relatively simple, but have some knowledge about ArcGIS and thoroughly investigate things like topology, which will affect your data. Let's continue with a brief software demonstration, and I'd like to show you in this next demonstration a little about some data I'm going to set a topology for. So I have several feature classes available in this environment, and I've already converted these. Now, quick view of them. I have boundaries, I have polygons, I have road right-of-ways, and I have vacant lands. These are all topologically integrated, but if I move the boundary of, say, the parcel boundary, I'd like to move the parcel polygon at the same time. In other words, I need to maintain the coincidence. So to do this, I have converted these shapefiles into feature classes in the GeoDatabase. So technically, I now have the data in a GeoDatabase environment. In order to maintain the coincidence, I'm going to create a topology. Right mouse click on the feature data set, choose New and Topology option. a wizard will appear that gives me the options of setting the topology. Name the topology, set a cluster tolerance, choose which feature classes participate, all of them in this particular case, and next choose the ranking. Now, I'm confident that land parcel boundaries are better geographically and survey specific. They're better than everything else. So I'm going to give them a low ranking. In other words, a higher relative importance, but road right-of-ways, well, they're a little less, and vacant lands, well, they should be at the same rank as parcel lands. So now I've set the relative importance of these data sets. In other words, I'm confident of land parcels, less confident of road right-of-ways. Choosing the next option, I have the ability to set the rules. And I'm going to set 2 of these to save some time. I'm going to set a rule that says land parcel boundaries may not have dangles. In other words, they need to always connect to each other. They have to close off, in other words. And I may set another rule that says land parcel boundaries must be covered by the boundary of land parcel polygons. And I specify. When I've completed setting the rules, I use the next option, and I get a summary. And if I finish, I'm prompted as to whether I would like to validate the topology. Now bear in mind that I don't want to validate this topology right now since it validates all the topology, so I'm going to choose no. If I view the topology, notice how everything is symbolized as dirty. This is the symbol for dirty areas. This gives me a cue to move along to the ArcMap environment. And in the ArcMap environment, I have brought into the ArcMap table of contents all the participating feature classes. If I turn the topology on, notice how everything is a dirty area in my study area. If I open up the topology, notice the specific symbology that has been applied to each of the different types of errors that I might find. Now, I have not validated topology yet. I'm going to do that in the next few minutes. Let's zoom in, and we're going to zoom in on a small portion of our study area where I happen to know there are some errors. What I'll do next is I'm going to start editing. And notice how the Topology Toolbar becomes active. The tool I'm going to use to validate would be validate in a specific area. So I'm going to validate the topology in my current extent. And if I zoom out a little, I'll see that only the topology in this study area here has been validated. Let's zoom back in this area and let's investigate some of the errors. Now, if I zoom in even further, I'll see that there are several undershoots and overshoots in my data. Zooming back, I'm going to use the error inspector to find specific errors and show you how simple it is to fix these. So, bringing up the error inspector, notice how the error inspector has arrived for us. Currently, none of the errors are being searched for. Let's search for errors that are dangling errors only. So we choose the option to look for dangle errors. Land parcel boundaries must not have dangles. And notice that I have several errors with respect to dangling errors. Pick one of these, right mouse click, and zoom to the error. And notice that I have the option of actually seeing where the error is. At this point, this error is an overshoot. So I have several different strategies. These are offered to me as potential fixes. A right mouse click will allow me to snap, extend, or trim. Let's trim this particular error with a distance of, say, 1,000 feet and use the enter button. And notice that as soon as the error has been repaired via the fix, and this happens to be too short a distance, by the way, a new dirty area has been added. Let me close the error inspector and let me zoom out a little. And notice that within my current area of validation, I now have another area that is invalid due to the fact that I have used a fix to correct this. More of this later when you have a look at further follow-up classes. Let's continue with a brief review of what we have covered. In this last section, we've covered the migration of your processes, the editing tools, and the GeoDatabase topology. Let's go over to Ben for some questions. Ben.
Thank you, Colin. I've got 2 questions here from David. David's first question is, in ArcInfo 9, can exceptions be tagged to persist between validations? And the answer to that is yes. When you mark an error as an exception, it is persisted in the topology class. So regardless if you've done a validation or not, you will be able to see that in the topology, through the topology class. His next question is, in ArcGIS, can you establish rules with map topology? And the answer to that is no. Map topology is strictly during an edit session, temporary topology that allows you to do some coincident geometry and some shared editing. But there's no rules that can be set up with the map topology. Another thing to note is that map topology can be used with an ArcView license in addition to the ArcEditor and ArcInfo. We have a question here from Michael D. in Las Cruces. The gist of the question is that there's a lot of tools in the toolbox, or in the different toolboxes and in Arc Toolbox in general. Is there a way I can put all of them in my own custom toolbox, so the ones that I use all the time, I can have them there and they're in an easy place and there's not too much clutter? And the answer is yes. You can move tools into your own custom toolbox and have kind of like a toolbox that you use all the time with your commonly used tools. Okay, there's another question here from Heather. And is the object loader a new feature of 9.0, or is it something that was available in previous versions? It was available in the previous version. It wasn't available in 8.3. Just remember that with the object loader, this is something that you would add to the customized dialog in ArcMap. Okay, we have another question here. Is the model builder environment available for ArcEditor 9? And yes, it is available for ArcEditor 9, also ArcInfo 9, of course, and then also the ArcView version. And I have one more question for me here. Does the traditional command line totally disappear at 9? And the answer to that is no. The command line for ArcInfo Workstation is still there, so you can use it, in addition to the new command line that you'll see with the new desktop ArcGIS 9. Okay, I'm going to turn it over to Colin now.
All right, we have a question from Tammy that's a very interesting question. The question is there a tool to automatically capture CAD annotation as an attribute in the resulting shapefile or GeoDatabase feature class? For example, I have lot number annotation as an attribute in a final parcel polygon shapefile. Tammy, the answer to your question is yes, there is a specific geoprocessing tool to convert CAD annotation to GeoDatabase feature class, and you may want to investigate using that tool via the modeling environment. We also have a question from Jason in Boise, Idaho, asking what is map topology versus GeoDatabase topology? Good question, Jason. Map topology is a light version of topology that allows you during a current edit session to edit features that are coincident. In fact, to maintain that coincidence between features. GeoDatabase topology is a more comprehensive and a lot more powerful topology in that it allows you to set a series of rules and ranking between these feature data sets or feature classes that you may be working with. So map topology was specifically created for ArcView users of the ArcGIS 9 product, whereas GeoDatabase topology, being more comprehensive, is used by ArcEditor and ArcInfo users. We have several other questions that would be very interesting for us to look at, and let me take one more question here. And the question is are topology features available at the personal GeoDatabase level? And the question here is easy to answer. Yes, some topology features are available at personal GeoDatabase level if we wish to. But I think it's time for us should we take one more question here? Right, we could take one more question. When loading coverage data into the GeoDatabase for the first time, which is the best method to do so? Well, there are several different options, but if you have an existing feature class that you would like to load your coverage data into, a good idea would be to use the simple data loader or the object data loader to do so. If, however, you do not have a target feature class to load into, I would recommend that you investigate using the straight feature class to feature class tool. Well, looks like we're running out of time here, so I'd like to point out that for more information, we have several virtual campus courses that you may want to look at. We offer Geoprocessing with ArcGIS 9, Creating and Editing GeoDatabase Topology with ArcGIS 9, and Creating, Editing, and Managing GeoDatabases for ArcGIS 9. We also have a free training seminar for you to attend called Working with GeoDatabase Topology, and this seminar will teach you a lot more about some of the topics that I touched on with respect to the topology, in fact the workflows that you might want to consider. We also offer several instructor-led training classes, one of which I would like to recommend to you called Building Geodatabases 1. This is an intermediate level class above the introductory classes that'll give you more information about the geodatabase specifically. For the data model information, I'd like to point you to support.esri.com downloads data model, and you'll find several very, very useful data models. And I might just point out that later in the summer, we have a new book being published specifically on data models. On behalf of ESRI, I'd like to thank you all for attending.